For the function f of x equals 2x squared minus 12x plus 18, we're asked to analyze the function with the goal of eventually sketching the graph of the function, the parabola. And we have a function here in the standard form, ax squared plus bx plus c. The first thing we're asked is to determine whether the parabola opens upward or downward. Well, my a value is 2, and so then since a is positive, the parabola opens up. We're asked to find the axis of symmetry. Since we have the equation, the function in the standard form, the axis of symmetry is given by x is equal to negative b over 2a. So then x is equal to negative. The b parameter is negative 12 over 2 times the a parameter is 2. Two negatives, that'll give me a positive. 12 over 4 is 3. So therefore, the axis of symmetry is x equals 3. Finding the vertex. We know the x-coordinate of the vertex. Since it must be on the axis of symmetry, I know that the x-coordinate of the vertex is 3. The y-coordinate of the vertex is the function's value at that input. So f of 3, that's 2 by 3 squared minus 12 by 3 plus 18. 2 times 3 squared, 2 times 9 is 18. 18. 12 times 3 is 36, minus 36, then plus 18. And 18 minus 36 plus 18 is 0. So therefore, the vertex is the point 3, 0. Finding the y-intercept. The y-intercept is the function's value at 0. f of 0 is 2 by 0 squared minus 12 by 0 plus 18. And so f of 0 is 0 minus 0 plus 18. And that's 18. So then the y-intercept is the point 0, 18. The point symmetric to the y-intercept across the axis of symmetry. Well, since the vertex is at 3, 0, and the y-intercept is at 0, 18, then to find the point symmetric, we have to go 3 units to the other side of the axis of symmetry. Let's go ahead and put some scale on the axes here. Let's use a scale of 1 on the x-axis. 1, 2, 3, 4. Let's make this 5. 6, 7, 8, 9. There's 10. And since I know I have to see all the way up to 0, 18, let's use a scale of 2's on the y-axis. 2, 4, 6, 8. Let's make this mark 10. And so then the top is then 12. So what we know so far is we have the point, the vertex is at 3, 0. And we have the y-intercept at 0, 18. And we know that the axis of symmetry is at x equals 3. So let me draw in that axis of symmetry here in green. And since my y-intercept is 3 units from the axis of symmetry, I need to go 3 units to the other side of the axis of symmetry, and I can plot another point on the curve. And so this point that's symmetric to the y-intercept is the point 6, 18. Now we are asked to find the x-intercepts, and really, we've already done that. We found the x-intercept at 3, 0. And I know that it's the only x-intercept, but because I know that the curve is opening up, since the parabola opens up, and I know the vertex, since it's opening up, the vertex must be the lowest point on the curve. That must be the only x-intercept. Let's verify that by applying the quadratic formula to the function. And the function for 2x squared minus 12x plus 18. So let's set the 2x squared minus 12x plus 18 equal to 0, and let's apply the quadratic formula. So then x would be equal to the opposite of negative 12 plus or minus the square root of negative 12 squared minus 4 by 2 by 18 over 2 times 2. Simplifying, that would give me 12 plus or minus the square root of 144, negative 12 squared is 144, minus 4 times 2 is 8, and 8 times 18 is 144. 2 times 2 is 4. So then x is equal to 12 plus or minus the square root of 0 over 4. Now the square root of 0 is 0, so we now have simply 12 over 4, which is 3. This tells me there is only one x-intercept. Specifically at 3, 0. I've already plotted that x-intercept at 3, 0. And so then graphing the parabola, I know 3, 0 is the lowest point on the curve, and so I'll just draw that rough U shape, hopefully trying to hit the points that I've plotted so far. And that's a very poor drawing. So hopefully I get something like this. So there in blue is the curve, the parabola for the function f of x equals 2x squared minus 12x plus 18.